2015 paper 1 question 8 part B. The spilled oil forms a circular oil slick 1 millimeter thick. Write an equation in part 1 for the volume of the oil slick in centimeters cubed when the radius is r centimeters. Okay, so you've got a circular oil slick and you're told that it is 1 millimeter thick. Okay, so that's the thickness of it is 1 millimeter. Now straight away before I go on, I'm going to change that to centimeters, because at the start you were told that the rate at which the oil spilled was 4 by 10 to the 6 centimeters cubed per minute. So your values were already in centimeters. So that's 0.1 centimeters, because there's 10 millimeters in a centimeter. So back to the question, we're asked about the volume. So first of all, it's a circle. So the area of a circle is pi r squared. And to get the volume, you just multiply your area by the thickness or the height, which is 0.1 centimeters. So it's that by pi r squared. Now in part 2 of the question, you're asked, find the rate in centimeters per minute at which the radius of the oil slick is increasing when the radius is 50 meters. Okay, so radius is 50 meters. So once again, I'm going to change that to centimeters. And that's going to give me 5,000 centimeters. So I'm asked for the rate in centimeters per minute at which the radius of the oil slick is increasing. So the rate at which the radius is increasing, the change in the radius with respect to time. That's what I'm looking for. This is a rates of change question. So I'm going to have to come up with a little formula equation here to find me dr dt. So what do I know? In the beginning of the question I was told the change in the volume with respect to time was 4 by 10 to the 6 centimeters cubed per minute. So that's definitely going to be important. So dr dt is equal to, and I'm going to use my dv dt straight away. So my dv dt from the start of the question. So what do I multiply dv dt by to get me dr dt? I multiply it by dr dv. Okay, now if I look here, I got my volume equation is 0.1 pi r squared. So I can find dv dr by differentiating, and I get 2 by 0.1 pi r. So dv dr is 0.2 pi r. And I'm not looking for dv dr, I'm looking for dr dv. So dr dv is 1 over 0.2 pi r. So back to my equation, dr dt, the change in the radius with respect to time, dv dt, which is 4 by 10 to the 6, multiplied by dr dv, which is 1 all over 0.2 pi r. Now I'm asked to evaluate it when the radius is 5,000 centimeters. So everywhere I see r, I'm going to put in 5,000. So dr dt is equal to 4 by 10 to the 6 by 1 over 0.2 pi by 5,000. And when we simplify that down, we get 4 by 10 to the 6 by 1 over 1,000 pi. And simplifying it down further, when you change 4 by 10 to the 6, you get 4 and cancelling down, you get 4,000 over pi, okay, centimeters per minute. That's what you were asked. And then just putting it into the calculator, you get 1273 centimeters per minute is the change in the radius with respect to time.